Now we've already created our example assembly. We've taken a look at applying some advanced mates, some mechanical mates, some standard mates, and we looked at ways that we can diagnose and figure out where problems are, how to get around problems by suppressing mates, moving things around, and ultimately getting to a condition that we're happy with our linkage. Well, there are many other mates that you need to be aware of. And of course, I've said this time and time again, this is a basic intro series. So there's no point in me making some very advanced examples to talk about these, but I do want to shed some light so you understand where some of these mates are. So let's go into mate and let's take a look by going back into mechanical mates. Now, inside mechanical mates, these are going to be types of mates that really help replicate advanced mechanical motion. We have cams, which allow you to create a cam and follower setup. We have slots, which allow you to place components in a slot and determine whether or not they're free to move in that slot or whether or not you want to lock it at a certain position or percentage of the slot. We have a hinge mate, which allows you to do several things. Now, most of these mates are conglomerations or sort of put together from other mates. The hinge mate automatically allows you to place a concentric, a coincident, and an angle limit on it. So when we select hinge, we go back up to the dialog box, you can specify angle limits, and that'll automatically place those concentric, coincident, and angle limit mates all in one shot. So it saves you a little bit of time. The gear mate, this can be very handy, but it does not account for gears meshing with each other. So it's very important that you understand that. When you place a gear mate, all you're doing is determining a ratio between two concentric parts or two round parts that are moving. So if you know that you have a 3-to-1 ratio between some gears, you can come in here, you can place a gear mate that does 3-to-1. If you're trying to actually look at the gear motion, the way that things mesh between each other, you're going to want to do a motion study. You're going to want to put a contact between two components, and that'll actually allow the gears to physically mesh. And it'll tell you if you're going to come to a condition where they bind up. You can apply things like friction between components. You can tell it what material it is. You can even give it mass properties so you can get an idea of the mass, the weight that's actually moving around rather than just having these sort of massless components on the screen. Rack and pinion, another very similar thing. You can do it by the pitch or you can do it by the rack travel per revolution. Again, this is not a physical relation between the gears on a rack and pinion. It's telling you as you rotate this one gear, how much does this other one travel in a linear fashion on a plane. A screw mate. This is kind of a cool mate that has been added semi recently. It allows you to determine not only a revolution, but also a distance that it travels. So, for instance, if you're trying to animate the assembly or disassembly of a component, now you can come in here and you can apply this screw mate that allows you to do things like turn a screw and have it go in or out. And you can do this based on revolution per millimeter or distance per revolution. Our file is metric, so it has millimeters. If you have a standard template, it's going to be in inches. This is a very handy way to go based on the screw thread pitch. And the last one in here is universal joint. So again, pretty handy. You can have components revolve. You can determine when you select a universal joint, you can define the joint point. So this is basically the intersection point of two lines as they go through. Pretty handy. It's not one that's used very often because they can get into a situation where they bind up pretty easily and so on. But if you need to use these sort of advanced mechanical mates to really show off your products, to show how they move in 3D space, they're all in here and they're all a very good option. There's one more thing in here. This is a very advanced topic, but there's an analysis tab. So the analysis tab allows you to do things like select a mate to what you want to add motion analysis properties. When you do a motion study inside of SOLIDWORKS, you apply forces, you apply springs and dampers, you do things like add motors and see how things move in reality. The nice thing about this is you can also export that data directly into simulation. So if you have full motion study, you have full simulation, you can apply gravity to components, you can see how they move and interact. If you do things like apply friction and forces between them, those forces and all the motion can be exported at certain time steps out into simulation. Again, very advanced topic, but the functionality is there. So you can really take your designs to the next level, figure out how they're moving, not only how they're moving, but how forces are applied. It's very handy for something like this where we have a linkage and we have spring. We could load a force on the swing arm. We know what the spring rate is. We apply the spring and damper force in the motion study. And we can analyze the dog bone here. We can figure out if it's strong enough, if it's going to bend, if it's going to deform past its limits, past its yield. All that can be done in a motion study. So all very handy stuff. Again, these are all advanced topics. The mechanical mates and even most of the advanced mates are going to be a little bit outside of the scope of a beginner introductory course, but they're there and I highly urge you to play around with them. Try to figure out instances where you would use them. Maybe you see the hinge mate, you want to figure it out. You make two components and you do a hinge, or you make two gears and you do the gear mate between them, or the rack and pinion, or whatever it is, and really take a look at those because they are very handy depending on your components. Of course, you need to come up with a component that matches those mates, or you need to figure out a component or an instance where you can use them. But very handy, very good functionality, and it can really save you a lot of time. You don't want to make parts that don't work in reality, so you can apply these mates and make sure that your motion is really what you expect and what you want.